Somewhere under a city, right now, a machine the width of an apartment building is chewing through wet clay. 100 feet down, above it, tower blocks, water mains, subway lines, people asleep in their beds, and none of it moves. Not a crack in a wall, not a millimeter, which should be impossible. Dig a big hole in soft, wet ground under a city, and the ground wants to do one thing: fall into it. So how do you dig the hole without the city coming down? The obvious way is to dig, then line the walls with concrete to hold them. And in solid rock, something close to that works. But soft ground under a city is not solid rock. It's more like wet sand at the beach. The instant you open a face in it, water and soil push in, and it slumps. There is no dig first, support later. The support has to be there the whole time, including at the one place you're actively removing the ground. So the machine does something clever. Instead of a hole, it keeps a sealed chamber pressed right up against the earth, and it pushes back. It reads the exact pressure of the soil and water trying to collapse the face, and it holds an equal pressure against them from the inside. It's a balance, and a delicate one. Push too little, and the face caves in and the street above sinks. Push too much, and you heave the ground upward or blow out to the surface. The machine has to live inside a narrow window between collapse and blowout the entire way. Now here's the strange part. What is it pushing back with? In the most common machine, the answer is the dirt it just dug. The excavated soil is pulled into that sealed chamber and kept there, under pressure. That churning muck, held tight against the face, is the thing holding the ground up. The waste is the support. To make it work, they inject foam and polymers that turn the soil into something like a thick, dense toothpaste, which holds pressure evenly and won't drain away. And to move forward, a giant screw slowly meters that paste out the back, exactly as fast as new ground comes in. Dig a little, let out a little, keep the pressure constant. That's the trick. And this is only one station in what is really a factory on wheels. Behind the spinning cutter head, everything happens at once. Hydraulic rams shove the whole machine forward. Right behind them, a robotic arm lifts curved slabs of precast concrete and bolts them into a complete ring, the finished tunnel wall. And the machine pushes off that ring to drive the next stretch. It builds the tunnel around itself and then shoves against what it built, which leaves one last gap to close. The machine is slightly wider than the tunnel it leaves, so there's a thin space behind each ring. If that space stayed open, the ground would relax into it and the surface would sag. So as the machine moves, it pumps grout into that gap at the same instant, locking the ring to the earth with no void left behind. Put it together, and a tunnel boring machine is one continuous process. Hold the face with pressure. Dig. Thrust forward. Build a ring. Grout the gap. Over and over. A few meters an hour, kilometer after kilometer. That's how it passes under a live subway or a row of houses and leaves them untouched. On London's Crossrail, the machines were held to less than 1% of ground loss, around 20 millimeters of settlement at most. They even weighed the muck coming out, load by load, to catch it if the machine ever removed a sliver too much. The ground above wasn't allowed to move, so it didn't. And it does all this blind. A laser and a target keep it locked to a designed path it can't see, hitting a point kilometers away to within centimeters. Then, at the end, most of these machines are never brought back. They're steered off to the side and buried, or dismantled underground. The mole digs its last stretch straight into its own tomb. The forecast, the elevator, the quiet in your headphones, and now the tunnel under your feet, dug by a machine holding a whole city up with the mud it removes. Once you can see one hidden system, you can't stop seeing the rest. Keep looking.